The way we're going to be doing composite operations, we're always going to be starting from the far right. So here, for example, I'm looking at g of 2. I'm using the g function, and the value of my variable is 2. So I'm looking at g of 2, that is 4 times 2 minus 2, and that should give me 6. Now I'm going to be looking at the outer operation, f, but in this case, I'm going to be doing f of this whole thing, so basically f of 6. F of 6 is equal to 3 times 6 squared minus 6. That is 3 times 36 minus 6, 108 minus 6. So I'm just going to call that 102. Same thing with number 12. I'm going to start on the far right, f of 2. So I'm using the function f and saying that value of that variable is 2. So I'm looking at that as 2 squared plus 1 should give me 5. Now I'm going to do f of 5. That is 5 squared plus 1, better known as 26. So that's composite operations. The hard part for this thing will be inverses. Let's take a look at number 13. First thing I'm going to do, instead of g of x, I'm going to write a y. So I have y equals 2 over x minus 3 plus 2. And then the y and the x are going to trade places. So I'm just going to write x equals 2 over y minus 3 plus 2. I see where the y is. It's a fraction. I want to have that by itself. So let me get rid of the plus 2. So I have that x minus 2 is equal to 2 over y minus 3. I want to get rid of fractions. So I'm going to multiply both sides by y minus 3. Notice the left I put parentheses. So the y minus 3 cancel out on the right. And then I get y minus 3 times x minus 2 is equal to 2. My left side, I'm leaving it in parentheses. I just know that it's times. So the way I'm going to get the parentheses of the y by itself, let me divide both sides by x minus 2. For space purposes, I'm going to move here. I get y minus 3 is equal to 2 over x minus 2. Now to get the y by itself, I'm going to say y equals 2 over x minus 2 plus 3. Right, let's take a look at number 14. I'm going to write this as y equals the cube root of n minus 1 over 2. The y and the variable are going to switch places. So let me write this as n equals the cube root of y minus 1 over 2. There's nothing outside of the radical, so I can get rid of the radical. If there was anything outside, I will get rid of that something. So in this case, I'm going to get rid of the radical. I know radicals and powers undo each other. So I get that n to the third is equal to y minus 1 over 2. Let me get rid of fractions. I'm going to multiply both sides by 2. So I get 2 n to the third is equal to y minus 1. To get the y by itself, let me add 1. So I get that 2 n to the third plus 1, it's equal to y. Lastly, let me take a look at number 15 and 16. Instead of g of x, I'm going to write y. So I have y equals x to the fifth. The y and the x are going to trade places. So x equals y to the fifth. To get the y by itself, I'm going to undo the power. Radicals and exponents undo each other. So I get that the fifth root of x, it's equal to y. Looking at number 16, I'm going to write this as y equals negative fifth root of n minus 1. I see the radical, but I see a negative 1 in front of the radical, and I see a minus 1 outside of the radical. Let me undo the minus 1. I'm going to move it to the left as a, well, actually, before I do that, the n and the y have to trade places. Okay, so now I was saying that the minus 1, I'm going to move it to the right as a plus 1. I get n plus 1. It's equal to the negative fifth root of y. I see the negative sign outside of the radical. I'm going to divide everything by negative 1. That way those negatives cancel out. So I get negative n minus 1. It's equal to the fifth root of y. So I divided everything by negative 1. Now, to get the y by itself, I have to get rid of the radical sign. That way I'm going to undo a radicals with a power. So everything on the left to the fifth power, it's equal to y.